Hey, how are you? Thank you for checking in. I just want to touch base on something real quick before we get into this particular lesson. And I just wanted to say how awesome it is that you're checking in, that you're doing what I'm asking you to do in this just craziest of times of remote learning. Never did I think I would be teaching algebra from my kitchen. And yet here we are. So if you're still in the game, and you're checking on math every day and you're watching a video or you're doing your IXL or you're completing your assignment through Google Classroom, I just want you to know I see it. I notice it. I check on assignment completion and stuff every day. I see those kids that are here every day and I appreciate that. And if you are that kid, if you're that student who's keeping up in real time and not falling behind, that really does say something about your character. It tells me that even in times of adversity and extreme challenge, which I would say this time qualifies as that, you've got what it takes to persevere. You're pursuing your knowledge and your education, and the fact that you've got that inner drive to learn and do well despite these challenges, I mean, that just says what a great kid you are, and I'm so proud of you. Huh. Well, let's talk about algebra so that I quit crying. How about that? I'm going crazy here. It's all taking its toll on me too, and my own children. We're all tired of remote school. We're tired of remote piano lessons and remote percussion lessons, and we're all just kind of ready for it to be over. So I feel your frustrations. I'm experiencing them myself as a teacher, and I see my kids struggling as teenagers. It's a tough time, but it's not forever, right? It's gonna get better, and I will see you guys again. Just not right now. So, who wants to talk about factoring polynomials? I bet you do. All right, let's try to get through this. I don't think I'm gonna have to do too many examples here, but we've actually been factoring polynomials for some time now, but there are so many different kinds of polynomials, and unfortunately, because there are so many different kinds of polynomials, the way that you break them down into their factors, it's not just one way. So we're on to this idea that sometimes when you factor polynomials, you have to do this thing that's called using the difference of squares. So we're going to talk about this here in a minute, the difference of squares. That's what this whole lesson is going to be about. Now, I'm going to post on Google Classroom, not today, but tomorrow, this sheet that I would really, honest to God, like you to, if you're at all able, print it out so that you have it handy. Well, if you don't have access to a printer, I'm going to suggest that you pause the video right now and write all this down. I call this the factoring checklist, or the 5 questions to factoring. This isn't all going to make sense quite yet because we haven't learned all these different ways of factoring. But this is a series of questions that as you start tackling these quadratics and we get further and further into the different kinds of factoring and the different kinds of quadratics, if you ask yourself these questions in this order, eventually you will land upon the technique you should be using. And you're probably like, what are you talking about? Just trust me, okay? Trust me. I even printed this out and gave a copy of this to my own son, right? So these are this is the factoring quadratics checklist, or the questions you should be asking yourself. First question, with every single quadratic we look at when we're trying to find our factors and break them down, is, can I factor anything out? That's something we've already done. We've already done this, can I factor anything out? Is there any number that you can pull out and set out to the side, and then if so, what would get left behind in your parentheses? So first question should always be, can I factor anything out? The next question is going to be, do I have 4 terms? If so, that's grouping. You haven't learned that yet. That's coming up. If you don't have 4 terms, maybe it's question number 3. Do I have a difference of squares? And aha, this is what I'm going to teach you today. We're going to learn about difference of squares. And if the answer to that is no, then you might have what's called a perfect square trinomial, something you haven't learned about yet. And if you get all the way through these and it's no, 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 then you're going to have to factor it the long way. I'll teach you the long way I kind of feel like we've already covered this, where two numbers add to b but multiply to ac. Oh, I'm losing my mind. Anyways, if we haven't discovered the long way yet, I think we have. No, I don't think we have. We're gonna go over that again. I think that's still coming up. Okay. What is a difference of squares? Well, they want us to do a little review. They want us to review FOIL method. So essentially, these are two binomials. We're going to FOIL them. This is just a review. This is not difference of squares yet. The answer that we get to over here, these are going to be what we call the difference of squares. So the answers that we end up over here in this column. So check this out. Let's FOIL this, right? X times x is x squared. Outers would be negative 4x. Inners would be plus 4x. And the last would be a positive 4 and a negative 4 makes a negative 16. So then we look at, always, you're looking to combine those middle terms since they're like terms. Minus 4x plus 4x, that cancels out, doesn't it? It creates a 0. So if you imagine that those two go away, what would you be left with? You would be left with x squared minus 16. This is a quadratic that we would call the difference because it's subtraction, and the difference of squares, because you could square root the x squared, right, that's x, and you could square root a 16, and that's a 4. Difference of squares. Let's do another. FOIL. 25x squared minus 5x plus 5x minus 1. That was FOIL. Minus 5x plus 5x cancels, so you're left with 25x squared minus 1. That is a difference of squares. It's difference because it's subtraction. You could take the square root of 25, you could take the square root of x squared, and you could take the square root of 1. Okay? Last one. 4a squared minus 6ab plus 6ab minus 9b squared. I FOILed that. The two middle terms create a 0, leaving you with 4a squared minus 9b squared. Is this a difference of squares? Is it subtraction? Yes. Could you square root of 4a squared? Square root of 4 is 2. Square root of a squared is a. Could you square root of 9? Yep, it's a 3. Could you square root of b squared? Yep, it's a b. So this resulting product that you get is called the difference of squares. Okay, so now what we're going to do is reverse the process. We're going to start with these, and I'm going to show you how to get back to here. So now the goal is to reverse operations. You're going to learn how to do that, and it's not hard at all. They give you a generic one here with just variables. It says to factor a difference of squares, use the following rule. Okay, here it is. It's going to be two sets of parentheses. What is the square root of the first term? The square root of a squared is a. So each set of parentheses gets an a, right? Because if you were going to FOIL this, a times a would be a squared. Now you're going to square root the second term. Don't look at that minus sign yet. Just ignore him for a minute. Square root b squared. And that's a b, right? So he gets a b in the first set of parentheses and a b out here in the second set of parentheses. Now, what goes here plus or minus? What goes here plus or minus? Let's look back to the examples we started with. Do you see that one was plus, one was minus? One was plus, one was minus. One was addition, one was subtraction. That is the pattern you want to use when you're factoring using the difference of squares. So this is going to be a plus, and this is going to be a minus, or addition and subtraction. Why? Why does it have to be that one is addition and one is subtraction? And the reason is, if one is addition and one is subtraction, that's where you end up with this plus and minus that cancel, the plus and minus that cancel, and the plus and the minus that cancel. Because you're setting yourself up for those middle terms to cancel when you FOIL, you're going to end up with a difference of squares. Now, Could you check your work? Of course you could. You could check your factors by foiling. So let's foil it. I know what you're going to end up with. You're going to end up with this, but let's prove it. First is a squared. Outers, negative AB. Inners, plus AB. And last, minus B squared, right? A positive times a negative makes a negative. Plus AB minus AB cancel, so you're going to end up with A squared minus B squared. And look, there it is. It's the same. So in a nutshell, if I could say this super fast, I would just say when you look at a difference of squares, square root that, one's plus, one's minus, you're done. Okay? Cool. Here we go. You're going to love this. You're going to hear me say it a gajillion times. Question number 1. Can I factor anything out? So I look at my quadratic. I think you can read that. That says n squared minus 64. Can I factor anything out of there? Can I pull anything out of here and also out of here? The answer is no. Do I have 4 terms? No. How many terms do I have? 2. Do I have a difference of squares? Difference? Square root that, square, yes I do. I have a difference of squares, so you're going to factor it using difference of squares. The square root of n squared is n. They each get an n. The square root of 64 is 8, so they each get an 8. And in order to get those middle terms to cancel with foiling, one is plus and one is minus. It's literally that simple. Okay? Let's do number 6. Let's do this one. Can I factor anything out? Nope. You don't have 4 terms, so it's not grouping, which we haven't even learned yet, so I'll probably quit saying that. Do you have a difference of squares? It's a difference. You can square root 1, and you can square root 49, and you can square root y squared. So yeah, it's a difference of squares. Square root of 1 is 1. Square root of 49 is 7. And the square root of y squared is y. And it's plus and minus. Right? Okay, they're going to get a little bit more complicated, so be patient. Let's do, I guess we'll do this one. Let's do 12. Okay. Can I factor anything out of a unit? No. It's a difference of squares. Yes, it is. Okay. Square root of 64 is 8. Square root of u squared is u. Square root of v squared is v. And because it's a difference of squares, one is plus and one is minus. Cool, huh? Okay, guess what? You think it gets harder? Nah, just a little bit. Nothing you can't handle. Let's do 20, and then I'll really put you through the paces here. Number 20, I'm going to tell you, can you factor anything out of a 64 and a 9? No, you cannot. Is it a difference of squares? Of course it is, because that's the lesson we're doing. The square root of 64 m4, okay, square root of 64 is 8. The square root of m4 is, check this out, m2. Square root of 9 is 3. Square root of n squared is n. So you're going to have to watch those exponents. And I know that's super tiny, but believe it or not, that is a 4. That's what that said. I'll write it bigger. This was the starting expression. Okay? So m4, when you square root m4, that's m2, m2. So watch that. Okay, now, we've got them all broken down into the square roots, and one is addition and one is subtraction. Okay? Okay. Now, this is where we step it up just a smidge. You know what? Maybe I'll switch to lined paper. I feel bad that perhaps you're not able to see clearly. Let me show you this. I'm going to call this number 22, only because, again, it keeps me straight where I'm at on my paper. Check this out. You're like, Lesnar, that's not a difference of squares, right? Because you can't take the square root of x to the third or the square root of x to the first. You can't do that. Right, I agree. You can't. It's not a difference of squares yet. Because guess what? You didn't ask yourself first question. First question, can I factor anything out of this? And the answer is, oh yeah. What can come out of a 36 and a 9? A 9 can come out. How about an x3 and an x1? They can both give up 1x. So here we go with first question. Can you factor anything out? You sure can. You can divide out a 9x and a 9x. Okay, so we do that. What gets left behind? That's going to leave a 4. And you took one of the x's out, leaving 2 behind. And you took out a positive 9, so that's going to leave a negative 1. And you took the x out, so there's nothing there. You're like, yay, we're done. No, we're not. No, we're not. It's cool that you factored something out, but guess what you created here? Difference of squares. Because you can square root of 4x squared and you can square root of 1. So now, this guy stays out here, and you're going to break this down into its factors. It's almost like you have 3 chunks to your answer now. What's the square root of 4? What's the square root of x squared? What's the square root of 1? And 1 is plus, and 1 is minus. So once you factored something out, then you could see the difference of squares. Okay? Let's do 2 more, and then we'll wrap this up. I'm jumping down to 28, which means nothing to you. It really only benefits me. 125 m3 minus 5m. First question. Can you factor anything out? Of course you can. You can take a 5m out. What would that leave behind here? A 25 m squared and a minus 1. Now, can you keep going? Did you create a difference of squares? Of course you did. That guy stays, but now you're going to break this down into square root of this, square root of that. 1's plus, 1's minus. The square root of 25m squared is 5m. And the square root of 1 is 1. That's it. That's your final answer. That's awesome. Good job. I lied. We're going to do 1 more of these, and then I want to throw 1 more at you. So sorry. So sorry. I'm just trying to pick which one I like. I like 32, which you're like, whatever, just get to it. First question. Can you factor anything out? You sure can. Guess what comes out? A 4 can come out of both, and an x. They can each give up an x. So take out a 4x, leaving behind 4x squared and a minus 25. Did you create a difference of squares? Of course you did. Let's break it down. Break it down. That's going to be a 2x. That's going to be a 5 and a plus and a minus. I chose a bad marker, didn't I? Yikes. My marker's going to retire here pretty quick. Now, I said I wanted to do 1 more, and that's true. Let me show you another one. Check this one out. Ugh, that's messy. Start over here. K squared plus 25. Can you factor anything out? Nope. Do you have a difference of squares? Do you have a difference of squares? No, you do not. And you're like, Lesnar, we can square root of k squared. We can square root of 25. You sure can. But you don't have a difference. This is not a difference of squares. This is the sum of squares. And this is trouble. Because I'm sure you're thinking, okay, let's try it. Let's try it. All right, let's try it. We'll do a k and a k and a 5 and a 5. There are no signs that you can put here, plus plus or minus minus or plus minus or minus plus, where you're going to end up with a positive 25 where the middle terms cancel. Not going to happen. So if you do not have a difference of squares and you can't factor anything out, this is called prime. So will you encounter prime quadratics from time to time or polynomials? Of course you will. And I just wanted to show you that one real quick, all right? I hope this makes sense. If it doesn't, you know what to do. Send me an email. We can maybe we can do a Google Meet or something, and I can walk you through a few. All right. Thanks for watching. Take it easy. Be well.